Okay, so welcome back. So let's look at the waste management concepts that we have been talking so far. So we'll continue our discussion that we were having on different aspects of waste management. If you remember, in the last video we talked about the 6 elements of waste management. So now in this segment, we'll try to focus on basically on the different treatment technologies that is being used and some other issues that we have tried to highlight in the very beginning of the first video for this topic. So in terms of integrated waste management, the most favored is, as you can see over here on this picture on the left hand side, the most favored option is to try to do source reduction. Then we try to go for recycling or composting, then some conversion technologies, and finally landfill. So that is what we are actually, this is the least favored, this is the most favored. So this is most favored, this is least favored. But as we all know, what happens is actually more and more waste actually is going to the landfill, then we do some conversion, then recycling, then source reduction is actually the minimal. So that's what we are finding. So same thing has been presented here in terms of what we really want to achieve and what is happening as of today. So if you look at in waste management, when we try to achieve something, waste management is it's a mixture of several discipline. It requires you to work with several discipline here. It's not only just like a engineering and all that. Engineering is a component. It's a major component, but you need to have some idea about the political science and in terms of trying to understand like a geography as well, like you have to have some geographical location, economics, public health, sociology, how to communicate, because one thing you need to remember, for any effective waste management plan that you want to do it for your city, you need to make sure that the people are on board, because every day's raw material, the waste that is coming in, is every day it is coming from individual houses. So if they don't cooperate, if they don't come on board with the plan that city is planning to do, it's very difficult to have a good effective waste management system. So communication is very, very key. How to communicate, how to make people aware, that's very, and the capacity building, those are very, very important. You need to understand a little bit of material science, archaeology, engineering, and all those things are important in terms of looking at. So that's why it says management. It's like when we talk about solid waste engineering and management. Engineering concepts are there, but it is actually beyond engineering. It's not only engineering, you need to have other stuff too. So when we say source reduction, we try to reduce the material in the product manufacture, make the product use lesser material, which is already happening. If you look at electronics and all that, things are we are becoming lighter. Try to increase the durability of the material, repairability of the material, decrease the material's negative impact. That's called toxicity. So if you can use safer material, that is also source reduction. Try to reuse material as much as possible. There are certain kinds of waste, certain kinds of discarded products that could be reused, like pallets, containers. Pallets is the bottom when you buy any heavy equipment, even for your refrigerators or washing machine, but you see that wooden frame at the bottom, which is there to support that weight. That's called pallets. That can be recycled. It is actually highly recycled material. Try to have an efficient use of material. So those are all relates to source reduction. There was a study done a few years ago where it was done in United States, where they found that in 50% of the waste quantity can be reduced with the source reduction. If we can do the source reduction, we can actually reduce 50% of the waste. There was a packaging is around 50% of the waste volume, 1/3 of the waste weight. So a lot of packaging, and that's what is happening in India too now with all these online shopping and all, especially during this COVID situation. These things are even increased further, where we see a lot of packaging waste coming out with the mall culture, with now those even for fruits and vegetables, there is a mall kind of stuff. So those all are increasing like packaging waste. They found that they are in the US. This study found that they were spending more on food packaging than farmers' net income. So farmers' net income was actually less than what was going into the food packaging. Of course, there are some initiative in terms of trying to do for a smaller, lighter, and degradable material. But again, it's a lot of it's creating a lot of waste out there. So if in terms of source reduction, they found that source reduction projects since 1991, that helps in terms of reduction of 5 to 15 billion pounds of chemicals in the environment. So toxic, this is a toxic inventory. That's a toxic release inventory. The TRI is your toxic release inventory. They found that 5 to 15 billion pounds, so if you can divide it by 2.2, that will be that much kg. So this much billion pounds of TRI chemical release was reduced because of this source reduction. There was drop in terms of release. Drop in release is sharp in the year the project is implemented and lasts for at least 5 years. So once the project was implemented, there was a sharp drop, and there was also it continued over time. So it was more. It was then 400, and there was a lot of since 91, close to 450,000 unique source reduction projects were implemented. Raw material modification was done, cleaning and degrazing changes were made, product modification was done to do the source reduction, as we talked about in the previous slide. Average projects targeting a specific chemical, they reduced from 9 to 16%. So there was a specific chemical, it was reduced by that. So it's in terms of those. So source reduction does work if it can be done. Segregation also, if you look at the segregation of waste in a material recycling facility, this is how a typically segregation work, and where the waste coming in, you have it is going through a manual. So this is your waste coming. Let's just a second. Why it stopped? Yeah. Okay. If I use that, it doesn't work anyway. So you have the waste coming in, which is coming, and then it is getting manually sorted. Cardboard is going separate, paper is going separate. Then we have aluminum taking out using eddy current separator. We have the steel using manganate. We have glass taken out, plastics, different types of plastics. So each one of them can be segregated, and different components can be segregated from there, and it can be made, and you can see things can be made, like different components can be taken out and can be used for different applications. So, and these kind of plants do exist. It's not that I'm just, you can look it up you will find on YouTube, you will find these plants. Even in Indian context, we are seeing some plants being set up along this line. Now, you can also take this, you are looking at an example of like a plastic recycling process. You have the plastic waste, different types of plastic waste out there, and you make granules out of that. You clean those granules, wash it, then dry it, and then extrude it, and then you get all these new pellets, which again can be used for producing new plastic material. So that kind of things is being done as well. So recycling, if you do, it saves precious resource. You don't need virgin material. Lowers environmental impact of mining processes. You are increasing the life of landfill. You can increase the efficiency of incineration and composting facility as well if you take those recyclables out, like metal, glass, plastics and other out. So it helps your composting facility. What could be the negatives? You have to make sure that it's done properly. If you don't manage it properly, you may create some Superfund sites, a contaminated site. Like some example, like waste oil recycling, newspaper de-inking, they do create superfund. You have to make sure that it is done properly. So you don't want to create soil, groundwater, and air pollution issues. And then you have to make this recycling comfortable for the consumer. If you don't make it comfortable and easy for the consumer to do, consumers are not going to do that. Next is our composting, where you take organic material, water, oxygen, go through that process. You can do composting at home, composting at municipal level. You have to maintain certain temperature, make sure the pH is around the neutral. You can there are different types like windrow composting, static pile, and all that is used for that. So this is a typical windrow composting. You have a compost pile, organic matter, as you can see over here. You have the organic matter, minerals, water, microorganisms. They are coming into here, and it goes through a process. heat is released, is an isothermic reaction, CO2 is released in oxidation, water is also water is there. You have, when you put some oxygen through it, because it's an aerobic process, then finally you get a finished compost of organic matter, minerals, water, and also microbes. That's your finished compost coming out of the composting process. Waste to energy, you can do either heat, you can do electricity, you can do both. Most common type is mass burn or combustion of RDF. You can do both. Mass burn is you take the material, bring it to the plant, take out any unwanted waste, any unwanted material which will not burn or which can create damage to the process. You take them out and you just do the burning. RDF is you make a refuse derived fuel. So RDF is actually better because you can have more efficient process. But to make RDF, again, you need to put some process. You will end up spending some resources there as well. So when we talk about waste to energy, it is essentially you are replacing, say, coal, and if you think about a thermal power plant, rather than using coal, you are using waste. So that's you can think about in a simple way. That's what it is. So you use the waste, which has good calorific value, produce heat. The heat will be used to do the steam. From the steam, you will use that from using the steam, you will generate electricity with a turbine and all like you do, and then you need to have proper air pollution control system there as well. So mass burn, waste will enter the facility, and we already talked about that, this material, and then it is forced. Some of this facility could be as big as 3,000 tons of MSW per day. And again, in the class, we'll discuss this in more detail as well. I'm just giving you a snapshot right now. And RDF, you take out all the material, then you waste, you shred the material, then you either burn it as it is called a fluff, or you process it into pellets and cubes to use as a fuel in other furnace. Material can be processed and packaged for resale as well, so that can be done too. For waste to energy, the pros: reduce volume of waste, recover useful energy. You can have steam, you can have waste heat. Incinerator ash can be used as a building material. Difficulty, like its cost, high degree of sophistication needed for operating safely and economically. There is a public perception of safety in terms of stack emissions, toxicity of ash, and all that. Landfilling is the last option. It's a concept which came in 20th century. Area of land which you put the landfill there, and were deposited on it in such quantity that you can see some elevation, surface elevation there. Nearly 50 to 70% of solid waste is landfill. You saw in the previous video a global picture, like how much waste is still going to landfill and open dumps and all that. So in terms of landfill, if you can look at, this is a typical landfill structure. We have a liner at the bottom, then we have a cover on top. There is a mistake in this picture. This particular thing should actually be outside. So there is no leachate collection comes out, and then you will have the sump somewhere here. So from here it will be pumped to this place, not the way it is shown over here. That's not correct. So we don't do it in that particular way. So advantages: carbon sequestration with a question mark, maybe. It does help in putting the carbon, but then you have to do biomining and recovery of the resources later on. Easy and cheap solution, yes, but then is it really cheap? We don't know. Will it may be cheap at a short term, but what will happen in long term? Because landfill, many people say landfill is like a band-aid solution. You are putting a band-aid. You are not really solving the problem. You are letting the problem be there for the future generation. Unless you operate it as a bioreactor landfill where the waste really degrades properly, and then rather than having a containment system, you are making it a treatment system. If it's a containment system, yes, you are making sure, you are ensuring that if your leachate collection system works properly, gas collection system works properly, then you will potentially you should not have groundwater pollution problem or landfill gas emissions issues. But it's a huge amount of resources which is lost. So we are losing all those resources, and then at the same time we don't know how long this liner will actually be intact. What will happen to liner in the long term? What will be the situation there? So it's better to use it as a treatment system rather than a containment system, and that's where the focus should be, rather than making this dry tomb landfill which can last forever. So those issues are there. Nutrient from leachate, maybe. Energy from landfill gas, this is possible. It is being done. It's a quick fix solution for hazardous and infectious waste. Again, that's also under a question mark over there too. So that's we have there is a question mark on that too. So this is a dump site on the left hand side. Dumps are open places where trash is buried and where animals, actually you see a lot of animals around there. They have no offer environmental protection, are not regulated that much. Landfills are carefully designed, engineered structure. In fact, landfill is one of the structure which uses application of several of the civil engineering courses that we teach. It is people say that it's a big application oriented stuff for civil engineering. A lot of aspect of civil engineering like hydraulics, your like geotechnical, several like geotechnical aspect, environmental aspect, even microbiological aspect. A lot of things actually goes into the landfill design and operation. So they typically use a bottom liner, and there is a daily cover and all those kind of stuff. So this is, you have geological barrier at the bottom. You put like a daily cover. You have a drainage layer. Then you have a stormwater drain. You have a landfill body by itself. Like you have a big landfill body. Gas collection system. You have a gas groundwater pollution, groundwater monitoring system. So there are various components of an engineered landfill is out there. So there are, if it's landfill, again, those disposal sites, as we talked about, typically they are pretty far from the city, so it is cost to collect, handle and dispose. We have the litter issues, we have the odor issues, and it's a good place where many of these insects and other things they grow. So, and it's a huge loss of resources. So sustainable practice, what we can do, expand sanitary waste disposal and landfill, develop infrastructure actually for waste utilization. We try to have more infrastructure, try to have compost facility, anaerobic digestion facilities, or waste to energy plants and all that. Integrated waste management and social inclusion. You have to get social inclusion there as well. Promote innovation in waste collection and treatment system. Support market economy for waste recycling. So development of market economy. Use digital mapping to manage solid waste. Ensure and implement integrated waste management system. So in waste management system, wherever you have looked at in terms of proper waste management system around the world, they come up with a better design of an integrated waste management. They design it for say 20-25 years, and then every 5 years they will revisit and look at it, what worked, what did not work, and then they try to refine that plan. In fact, myself I was a co-chair of when I used to live in Canada. I was co-chair of the city that I was living in the solid waste management master plan review committee, where we looked at the master plan for 25 years, and then we also looked at every 5 years, and we try to look at how to make things work and what didn't work over last 5 years, learn from it and try to improve our plan as we make progress. So that kind of thought process is required in every city and towns in India. We need to have that kind of thought process. There are a lot of local universities and local people who will be interested to help, but the government agencies has to take the lead and they'll have to make it happen, where you bring all the different stakeholders on the table, have a detailed discussion on how to fix the waste management problem, come up with the plan, realistic plan. Don't do plan just for the sake of planning. Don't do just come up with a realistic plan and do it once, like go for it step by step. Don't try to go to the moon on the first time. It does not happen that way. So it takes time. It will take time, but we have to take the correct step in the correct direction. Then only we'll reach the final destination. We try to make a big jump, and then what happens is we basically end up nowhere. We come back to the same position every few years. So there are a lot of like we have to get the citizenship involved. Try in terms of as a citizen, avoid single use, add extra cost to single use item, provide recycling for the organic waste, partner with organization and all that. So a lot of things can be done over there. There are a lot of things you can do to reduce your food waste, reduce your own waste. So how to try to reduce your stuff, that also helps in like buy second hand, shop ethical brands, reuse bags, pack your own lunch, learn to compost. So all those examples are out there which helps you to do a lot of things by yourself. Add sustainability, like have an economic value, and look at environment, look at government, look at humans. We'll have some discussion on that in the class when we discuss it in class. So we look at an integrated approach for sustainable waste management. In terms of sustainable waste management, you try to, if you look at the hierarchy, you can start with try to have waste reduction to start with, recycling, mostly informal recycling happening in our country. We can go for anaerobic composting, anaerobic digestion. I'll call it anaerobic digestion rather than composting. So we can go for anaerobic digestion, make biogas for source segregated organics. We can have a small scale biomethanation plant. We can go for large scale biomethanation plant. This is coming from NCAWI, their website, their suggestion of how we can potentially go for sustainable waste management. Then we can go for aerobic composting of whatever is reject coming from there. We can go for either windrow or vermi. Then we have plastic waste to energy, gasification, pyrolysis, RDF, incineration, and all that. Then modern landfill, whatever is cannot be done so far goes to a modern landfill. We try to use methane recovery, and then ultimately we try to avoid having this unsanitary landfill and open burning as much as possible. So that's hierarchy we need to follow. In terms of how waste management has developed, I just wanted to give you a very simple, like I told you that we'll try to have some global snapshot. This is in New York City. In 1880s, they started looking at waste management, but it was basically there were nothing. It was dumping the waste at a sea harbor, in a sea in a New York harbor. Then in 1900, they started having the collection. 1900 refuse collection wagon used in America. Then Federal Water Pollution Act came. Then post-war 1964, there was they started thinking about we have to do something about it. 65 Solid Waste Disposal Act came. 70 they had the Resource Conservation Recovery Act, which is the Solid Waste Management Act today. Then RCRA was revised in 76. 80 they had Hazardous Waste Management. 84 they had amendment of that. They had Environmental Protection Act, Hazardous Waste Management and Handling, Municipal Solid Waste Handling in 2000. These are the Indian ones. So up to 1984, it was all coming from like a US side. And the green ones are the Indian scenarios, where 86 we have the Environmental Protection Act, 89 we had the Hazardous Waste rules, 2000 we have the Municipal Solid Waste rule for the first time. Then we had the biomedical waste, batteries waste, e-waste and plastic waste in 2011, and in 2016 all these waste management rules were revised. So as you can, so we have started late, so it will take us for some time, but we have to make progress in correct direction. So this is again showing you the example and of what is like showing the timeline of waste management in policies and activities in Indian context. Some of these we have already covered. Some are kind of new here. There are several committees in between which looked into waste management. The CPHO manual was developed. CPHO manual was revised. We have the Swachh Bharat mission came in, National Action Plan for Swachh Bharat mission. Then we had a National Green Tribunal Act, which also helped. And then in 2016, as mentioned, we had several rules were revised. And then 2018, we have this new e-waste rules was also revised further in 2018. So a lot of activities happening in India. In India, this is the last CPCB report, which is available on their website. It says that we generate around 62 million tons of waste. 70% of that gets collected. And out of the collection, only 25% is treated. So rest, many of it goes in dumped in online landfill. We have some compost facility, we have some biomethanation plant, some RDF facilities, some waste to energy plant, and many of these plants are also struggling from techno-economic point of view. So they are creating there is issue on that. Rules, there is we talked about that, solid waste management rules and all those. You can see the different guidelines which is already available in for the different government agencies and the private agencies who wants to work on it. So a CPCB in compliance with NGT, they also came up with some manual, some guideline. Manual is also developed by CPHO, which you can have. I think it's over here. So there is a CPHO manual on waste management, which came in 2016. So typically, in terms of, I'll not go in more detail in this video right now. We can talk about that in the class. This is how the organizational structure is in terms of the rule. You have different ministries, different agencies over here, and then we have the industrial units, manufacturers, brand owner, waste generator. So waste generator is also one of the player now. Source segregation of waste, we have talked about that. wet, dry, domestic, hazardous, at least do that. There is a user fee now. There is a spot fine also. Concept of partnership in Swachh Bharat, where bulk and institutional generator, market association, event organizer, hotel have been made directly responsible for segregation. So those things have been done. All resident welfare association, they and the gated community, they have to do segregation at source, where dry and waste, hand over, recover, recyclable material to authorized waste picker. Biodegradable waste should be processed. Composting or biomethanation is encouraged. All manufacturer of disposable product who sell or market which are non-biodegradable, they have to collect back the packaging waste generated as part of the EPR, extended producer responsibility. Concept of RDF and the need of WTE is also, waste to energy is also there. So when you have to do the segregation at your home level, if you look at the biodegradable, these are the component you need to think about putting in the biodegradable. These are the component which goes to recyclable. Some is like in Bangalore, as you can see, they have gone into great detail in terms of telling them what should go where. So every city and town has to have these kind of segregation chart for their residents, and then providing them proper infrastructure for its not only doing the source segregation at home, but also collecting the source segregated waste. Zero waste is again a concept where you try to reduce the waste as much as possible. You try to refuse. So refuse, reduce, reuse, recycle, and compost. So they call it ROT. So 5 R's, 6 R. You will see a lot of R's these days being used, but essentially it means that let's try to minimize waste as much as possible. That's what it's all the concept is. So how will you go? Establish your way, assess your waste, prioritize. There are some people who make only 1 jar of trash a year. So there are Planet or Plastic in that you look at, there are some people who are taking those initiative. In National Geographic website, they talked about that. Replace item as they run out. Research how to properly recycle. Remember, it's a process. It takes time. It does not happen overnight. So zero waste self-care, bamboo toothbrush, a steel razor, saving brush, bar shampoo, bamboo comb. You have a natural deodorants. Then you have homemade cosmetics. So zero made in kitchen, how we can do. So reusable bag, glass jar, reusable containers and all that. So it gives you an example of how you can go towards zero waste as much as possible. Reduce consumption, reusing discards, principle of producer accountability, comprehensive recycle, comprehensive composting or biodigestion. So try to do all that to move towards zero waste. So to make any of these possible, we need citizens' participation. A ban on waste incineration and illegal dumping, systematic reduction of landfilling, so effective policies, regulation, and then financing structure, and having proper capacity building. Capacity building as a intellectual capacity and also infrastructure capacity. Then e-waste, we all know, like we all produce e-waste in terms of cell phones, computers, monitors, printers, audio, video devices, small devices, other equipments. So e-waste is a general term used for any obsolete, old, disposed, which is connected to a power grid or contain electronic components. So in terms of e-waste, in 2010 there were 51 million computers disposed, of which 60% of those were thrown into the landfill. And that's only 2% of the, again this work is from the US, that they found that only 2% of the trash was e-waste, but that contains 70% of the toxic metal in the landfill. So because of the metal containing there, 40% of the lead is actually coming from electronic waste in the landfill. Lead has, we know lead has a health risk and damage to the central and nervous system. That's why we have phased out lead from our petrol. You go to a petrol pump, it says unleaded petrol. Why it says unleaded? Because there was lead at some point of time. So we have get rid of lead because it has negative human health impact. So recycling can save, recycle can also, these are all the different elements which is out there. So 1 metric ton of electronic scrap contains more gold than recovered from 17 tons of gold ore. So 1 metric ton of electronic scrap, actually electronic scrap is actually has a better gold than many gold mineral there. If you go for gold mines, the raw the raw material that you get for your to process that, actually you can process electronic waste that is actually better. So if you compare that to computer reuse created 296 jobs for every 10,000 tons of material disposed each year. So that will help you generate that much jobs as well. So these do generate jobs. So these things does help in creating more jobs and all that. So global e-waste, if you look at there are a lot of e-waste, 44.3 metric ton of e-waste is undocumented. Then we have 7.3 kg per capita, will reduce a lot of things in the environment, and again we'll talk about that in more detail in the classroom. Then you have this global e-waste. If you look at what is there in the small equipment, large equipment, and these are based on weight, so that's why you see that these are temperature exchanger, screens, small IT, mobile, and all those phones and all that. So life cycle of an e-waste, as you can see, higher level of disposable income that is leading to more waste. Again, America, Europe leads in terms of waste coming out. Asia, because we have a lot of people here, 53.6 metric ton, 7.3 kg per capita, that is generation of e-waste. Urbanization, industrialization, all those things are related to a lot of e-waste. Now, in terms of policies, we are making progress. In 2014, we have 61 countries in terms of having e-waste policy, and here now we have in 2019 we have 78 countries. So we are making progress in this area as well. So if you don't manage e-waste properly, it is creating a lot of problem in terms of soil, water, air pollution, bioaccumulation of metals, and all those stuff. So we need to have a proper management of e-waste. In terms of managing, you can shred, or whatever the plastic, metals, and glass component that could be recycled as it is. It is that precious metal when you have those the metallic powder which is coming out. So first you do the shredding and pulverization of waste PCBs, which is printed circuit boards, do magnetic separation, gravity concentration. Then you do the electronic separation, non-metallic powder, metallic powder, and then you go for all these like a pyrometallurgical and hydrometallurgical process like chemical leaching, and you get all the different things coming out. So these are different technologies out there. There are a lot of research needed in this area as well. So we have hazardous component in terms of CRTs, circuit board, batteries, and mercury lamps. We have some plastic, metals, wood, which can be just used up. These are non-hazardous components. So we do sorting, testing, and disassembly, and non-hazardous can be recycled. And hazardous should not be sent to the landfill. We can try to do some resource recovery from there. So e-waste as a resource, through metal recovery, you can have silver, gold, palladium, platinum, all these different things are present in the e-waste. So if you can recover these, they are actually, we need process to effectively recover these materials. So hydrometallurgical process is there. Many people are working in this area where you take the e-waste, and you go through in terms of cyanide leaching, acid alkaline leaching, thiosulfate, thiourea, halide, and then try to come up with this recovery of electronics, different components coming from there. So global, in terms of alternative energy, you look at solar, wind, hydro and ocean, hydropower, geothermal, and bioenergy. So what about the waste coming from solar and wind energy? Like what will happen to those? So we try to have quickly we'll look at some of those issues. So if you look at the solar panel waste or wind turbine waste, so we are going to see a huge amount of things coming out. If you look at the regular loss scenario or the early loss scenario, because of some breakages and all that, by 2050, 78 million tons of PV panel waste will be there. So just recently, in one of the master's student did a work on looking at the solar panel waste. We have submitted that paper just a few days back. Let's see what happens with that paper. We are very hopeful that that should get accepted in a good journal, where we looked at solar panel waste, what is the environmental impact from there. Then global wind turbine or blade waste, again, you can see those numbers are expected to go up quite high, and they will create, we will have if we manage it properly again, we can create because we'll have more and more solar panels being used, that we can create some value if we can do the raw materials recovery, the resource recovery from solar panel waste. That is, by 2050 we are looking at $15 billion industry. So that's, and 2030 we are looking at 450 billion industry. So new industry development is required. So a lot of new industry in this area has to come out where we can use this material. Wind turbine, again, you can make a lot of material from there. As you can see, a lot of carbon fibers, things can be done. It will be shredded, grinded. So wind turbines, value creation can be done from the wind turbine as well. So overall, we have to look at a kind of a circular economy solution, reduce environmental footprint, try to go for cleaner production, better service, collect the end of life, recycle, reuse as much as possible. So try to minimize waste, reduce environmental footprint, generate increased income, reduce resource dependency. Try to decouple growth. Try to decouple the growth from our economic growth. So that try to decouple resources from economic growth. So if we can do that, that will really be helpful. So thank you. This kind of covers the overall the waste management part. I did go through a bit quickly over the material because these videos are like just a summary to give you an idea, and in the class we'll have more time to discuss this aspect. So thank you again, and see you with the next topic like few days later.